Think about the last time you tried to build a machine learning model for a real business problem. You probably started with a clear idea. You had data. You knew what you wanted to predict. But somewhere between the first notebook and the moment that model was actually serving users, the project got stuck. It is not because the model was inaccurate. It is because the infrastructure required to keep it running was too complex. This is the central tension in the current state of artificial intelligence. On one side, there is the promise of automated platforms where you upload your data, describe your goals, and get a production-ready model. On the other side, there is the traditional path of building your own machine learning operations stack using tools like Kubeflow or TensorFlow extended. The promise of the automated path is compelling. It suggests a future where the heavy lifting of infrastructure is abstracted away. You simply hand over your dataset and your business objective. In return, you get a system that trains, validates, and deploys your model without you needing to manage the underlying containers or orchestration layers. This is the value proposition of a platform like Melon. It treats model deployment not as a software engineering challenge, but as a data science workflow. The idea is that you should spend your time on the logic of the model, not the logic of the deployment pipeline. However, we need to look past the marketing and examine the financial and architectural reality of this choice. When you choose to build your own stack using open-source tools like Kubeflow or TensorFlow Extended, you are trading upfront speed for long-term control. You are essentially becoming the infrastructure team. You have to provision the compute resources, manage the Kubernetes clusters, and ensure that the pipelines do not fail when the data schema changes. This sounds like a straightforward engineering task, but the hidden costs are where the budget bleeds. Consider the engineering hours required to maintain a custom MLOps pipeline. It is not just about getting the model to train. It is about monitoring the data drift. It is about setting up automated retraining triggers. It is about ensuring that the inference engine can handle 100,000 requests per minute without latency spikes. Every time a new team member joins, they need to be trained on the specific architecture of your stack. Every time a dependency updates, you risk breaking the pipeline. This maintenance burden is often invisible until it is too late. By the time you realize the system is brittle, the engineering team has spent more time fixing the pipeline than building the actual intelligence. Now consider the alternative. If you use a platform designed to abstract this complexity, the financial model shifts. You are paying a subscription or a usage fee for the platform instead of paying for the full-time salaries of specialized infrastructure engineers. The calculation is not just about the monthly bill. It is about the opportunity cost. When your team is focused on maintaining a Kubeflow cluster, they are not innovating on the model itself. They are not testing new hypotheses. They are debugging Kubernetes pods. The velocity of production is the key metric here. A team using an abstraction layer can iterate on the model logic much faster because the deployment pipeline is already built and tested. But there is a catch in the promise of automated platforms. The research into this space reveals a critical gap. The core challenge of getting a model production ready is not the training accuracy. It is the operational behavior. Models often behave unpredictably in live environments until they are deployed. A model that looks perfect on a validation set might fail miserably when the real-world data distribution shifts. This is where the distinction between a simple upload tool and a robust platform becomes vital. A true production-grade solution must include automated testing, monitoring, and continuous feedback loops. It must handle the convergence of automated data pipelines and rigorous benchmarking. This is where the financial comparison becomes nuanced. A platform that only handles the upload and deployment without addressing the operational reality is a false economy. You save on the initial setup cost, but you pay later in the form of model failures in production. You need a system that understands the lifecycle of the model. It needs to know when to trigger a retrain based on performance degradation. It needs to manage the context of the project so that changes to the data do not break the inference. This requires a level of sophistication that goes beyond simple automation. So, when you are making the decision, you must ask yourself what your actual bottleneck is. Is it the speed of deployment, or is it the reliability of the model in production? If you are a startup trying to validate a hypothesis, the speed of the automated approach might be worth the risk. You can iterate quickly and learn. If you are an enterprise running critical systems, the stability of a custom stack might be necessary. You can tune the infrastructure to your exact needs, but you must accept the cost. The hidden maintenance costs of the custom stack are real. They are not just about server costs. They are about the cognitive load on your team. The path to production-ready models involves a convergence of these approaches. We are seeing a shift from isolated model training to end-to-end lifecycle management. The tools that succeed will be those that offer the velocity of an abstraction layer while providing the visibility and control of a custom stack. They will bridge the divide between development and production. They will ensure that the model behaves as expected in the live environment. This is the maturity that the industry is still striving for. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.